Okay, so what we've seen thus far is we have seen a man busy walking, so that's kind of a real life situation, and we've wanted to take that real life situation and create a model or develop a model. And what did we mean by this model? We meant that you could take that man walking and you could extract some quantitative information and represent that in a table. We've seen that already. Represent it on a graph, or even represent it as a mathematical, we haven't gotten to this yet, but a mathematical equation. Okay? These are ways of representing some real life situation in a quantitative way, so that you can visualize it, or you can see it on a table, or you can use it to calculate other things, which we'll see in a second, or possibly in the next video. So what did we see is that we represented that man's position using a position time curve like this. And what happened was, if you recall, every third of a second, starting at 0, every third of a second, we looked at his position, every third of a second. So at every time when it incremented by 0.33 seconds, we looked at his position, we captured his position. Okay, now what would happen if we kept making this time smaller and smaller? Say time was 0.1 second. Every 0.1 seconds, what would happen if we captured his position? Or if we made the time 0.01 seconds and we captured his position? Or we made the time even smaller. The point is, what happens if we keep making the instant where between frames, if you will, or between times where we captured his position? If we kept making this smaller and smaller, we would end up practically with a curve like this, or like this, a curve. Instead of these discrete data points, we would end up with a curve. So another way of representing this capturing of his position at smaller and smaller times is really to interpolate, okay? So go and check out what this word interpolate means if you don't know. But we're essentially drawing a line between the data points, okay? So now, instead of these discrete points, we've got a curve, okay? And this curve then can help us find his position between these data points. So say now you only have these data points, but now what we've done is we've interpolated and we've drawn this curve, and now we want to find what is his position at say this time. What is his position at this time? Then because of our interpolation, we're able to then find his position at that time. Originally, we only had these discrete data points, but now we've interpolated so we can find a time between these data points and find his position. So here's another a representation of a curve, and eventually what we'll see is that these curves not only can be represented in such a way on a graph, but they can actually be a mathematical function, x of t, meaning the position as a function of time. It could be something that looks like this, I don't know, minus 3t squared. Or it could be something that looks like this, say 2 plus 4t, right? These are functions of time. There's the time. So your position is a function of time. Okay? So we'll do an example in the next video.